This is video 66 on a MicroPython LVGL embedded solution. LVGL has 30 plus widgets. An LVGL widget has a basic shape and functionality when created. One can style and configure a widget to make it visually interesting. In this video, we learn how to enhance a slider widget and buttons. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. Our test rig is the device that uses an ESP32-S3 USB board that is wired to an ILI9341 display with a standard XPT2046 touchscreen. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to improve LVGL widgets, and we start with an example using a slider and two buttons. We will enhance the slider's indicator to improve the user's understanding of the sensor data. We'll incorporate images in the slider and buttons to make them visually appealing. We'll improve the code reusability by organizing our custom widget into a class. This effort could be the beginnings of a beneficial library module, but could the maintenance effort become too big a burden? By keeping each class simple, we hope to keep it relevant for future projects. And now for the demo. Here's the first program, test_slider_display. As you can see, it's very similar to the test slider program that we've used in previous videos, only we've added two buttons. The right button will increment the slider value and the left button will decrement it. Additionally, we can move the slider to any value we want just by clicking on the knob. All right, let's reset the display and start the second program. Here's the second program. It's test_slider2_display. And you can see it's visually interesting. The buttons have been changed to images of buttons, and the slider knob has got a red pointer to show you the value on a scale that's been added just below the slider. Let's click on the buttons. And of course, we can click anywhere. All right, you can see that the improvements are nicer. And that was the demo. As research, we searched the LVGL forums for examples of useful techniques and code snippets for microcontroller displays. We found an example of the best way to add images to a MicroPython program. As you saw in the demo, we chose our test slider program to improve with images. We used Microsoft Paint to create a simple red arrow in which the file is 32 by 32 pixels. Then, an internet search helped find freepik.com, which has PNG and SVG format images that can be downloaded. It's important to use our search mechanism on images with a free license. Just in case, we include an acknowledgement to freepik.com in our code in this video. Let's next discuss the hardware wiring and then look at the code. Our display and touchscreen can share an SPI port, so our wiring just needs 7 unique pins on the MCU. Notice that the backlight is always on. If desired, you can add another MCU pin as digital output to programmatically control the display. The program and the standard driver files can be downloaded from our GitHub site mentioned in the endnotes and description of this video. The files on this slide should be uploaded to the flash directory of your microcontroller using a tool like Thony. Note that the only file that you should edit is the display driver, as it contains the display type and its pin definitions as well as the screen orientation. We will walk through 3 programs. The test slider display program shows the simple statements needed to display a slider widget and control. The test slider 2 display imports GUI objects from a separate module called widget. The widget module contains class definitions for custom LVGL widgets. This encapsulates the code, making it easier for a developer to apply the custom widget to a project. The widget classes are simple, and if needed, a developer can further refine the object in their project. Let's look at the first program, test_slider_display. The first program is quite simple. It has the standard definition for a screen. It creates a background. It creates the slider. There's a slider callback. And we can use it to get the value and display it. Here's the label that contains the slider's value. Finally, it has 2 buttons, a right button and a left button. And the buttons are simply there to either increment the slider value or decrement it. And we have the callbacks, and that's the slider program. All right, let's look at the test_slider2_display program. All right, the difference in this program is that we are using the widgets that we got from this file, widget.py, that's on the flash of the device. It brings in 3 classes: convert PNG, gauge slider, and image button. Of course, we defined the screen as before. We've set it, the color, either to black or to white. At the moment, it's set up as white because we've commented out the statement that makes the screen background black. But we can test it, and here we've got an equation that will set the variable dark either true if the screen is black or false if it's a different color, like white. Here we're brought in the PNG files that are on the flash drive and converted them into an image data that can be used by the LVGL widgets. Here's the same label that we had before. And now here is the slider. You can see it's using a gauge slider, which has been defined with the arrow image, the label that's going to update its location. By setting it to 0, it will center on the display. And an indicator of whether the display background is dark or white. In this case, it's white, so this value is false. Next, we set the value of the text of this label, and we set the current value. As you recall, in the test_slider2 display program, the value initially was 40. Again, we can test to see if it's dark. If it is, that we can set the text colors to white so that we can see them, but that's not needed in this case. Here's the definition of the buttons. A button is defined as an image button. Here's the image. Here's the size in pixels of the button, which is essentially a circle. And then here's where we're displaying it on the screen. We use variables from the display to get the width and height and position it as we need it. Here's the left button. Callbacks are very similar to what we had in the previous program, but they're simplified in that we only just need to say the right button dot action and give it the name of the callback. Now let's look at the widget. This is the widget file, which has been loaded into the flash of the MicroPython device. It's going to define 3 classes. The first one is convert PNG. And this is essentially the code that we found on the forum site. So you see here's the get image data, the create image, the convert routine, and in case you print it out, there's a string that will tell you which image you're looking at the moment. All right, the gauge slider is initialized with the image, the label, its location, and as you recall, if we have 0, 0, then we're going to center it, and whether the background is dark or not. We continue to initialize the variables within the class. If it's dark, we set the colors accordingly. So we're going to want white colors on the background for the faceplate for the slider, as well as the border. And here's the code where we test to see if we need to center it or not. So what we did is we created a container right here. And this container is going to contain the slider and the scale. So the container is essentially our faceplate. So here's the slider definition. And here's the scale definition. And again, we set the colors. In this case, the colors are set to black by default. But if you choose, you could have a black faceplate and change the tick marks to white. Finally, here's the knob. And we use a style to hold the image of the arrow. And then we apply the knob style to the slider. And you can see here that it's LV part knob that gets updated. Then we do a pat all, as that's recommended to ensure that the image is located where you want it. We set the background to transparent. We get rid of the knob's border width, but we include a border around the slider itself to make the whole slider bar be visible to the user. And finally, we add event callback. One thing we had to do was set the scroll bar mode to off to prevent the screen from allowing us to scroll the display. We wanted the display itself to stay static and not move around. Here's the routine that we use to set the text of the label. And whenever the callback occurs, it uses this update routine to update the text. And here's the way we use methods to set the value, and here's a method to get the value. And then the slider callback just calls that update. And the reason we did that is one can, outside of the slider itself, set the value, and we wanted to make sure that if you manually set the value through program code, that also will update the value on the label. Here's the image button. The image button is defined, of course, with an image and its width and height by default. You can see that it's a regular button. LVGL does define an image button, but it's no different from this button, and I didn't see any benefit from using it, as this was actually easier. So we use a regular button. We set its size and position on the screen. In this case, if they are, the height and width are equal, which they are, we've set it 48 pixels by 48 pixels. Then it's going to set the button shape to round. It's going to make it transparent so that it floats on that background. And here's where we've applied the image into the button. Okay, and the last bit is the action. The action is just calling the button's event callback, and it's just making it easier for the developer, since we know that we want to do this event on a click and we want to set this variable to none always. It just does it for you. And that's it. This is a good start on a simple library module to make our program easy. And that's it for the code walkthrough. In summary, in this video, we demonstrated a code example of a better screen using an improved slider. We discussed our approach, we discussed the test rig wiring, and we walked through the code. We hope you found this custom widget interesting and can find a way to incorporate it into one of your projects. Thank you for listening.